Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.7, day 2, entitled Inequalities. And today we're going to talk about the last two objectives. We're going to solve absolute value inequalities, and then we're going to model with inequalities. And remember that word modeling just means we're going to have a word problem that we're going to have to solve. So when we're dealing with absolute value inequalities, remember, we're going to get two solutions. We're going to set them up very similar to how we set up an absolute value equation. And then we're going to put our two solutions on the number line, and we're going to decide if we need to shade between them or in opposite directions from them. So basically that rule that we talked about the other day with less thans representing an and graph will still apply, and greater than representing an or graph, that will still apply as well. So we have just two examples to look at today. For example 6, this is a fairly basic absolute value inequality. And like I said, we're going to set up our two inequalities to solve them. And we're going to set up one inequality that looks just like the absolute value inequality, except we drop out those absolute value bars. So we'll have x minus 9 is less than 8. And then we're also going to have x minus 9. And usually when we set up our two equations, I have my students change the sign on the 8. So it goes from positive 8 to negative 8, which we're still going to do. But when you do that, you have to also flip that inequality sign around. So when you set up your case, your second case, it's really important to remember to switch that absolute or that less than to a greater than sign. And remember, since we're starting with a less than sign, less than means and. So this is going to be an and graph when we get done, which means we're going to shade between our points. If it was a greater then we would have an or graph. So less than is and, greater than is or. So now I'm going to solve each of these. Add 9 to both sides here. So now I'll have x is less than 17. And same steps here. I'm going to add 9 to both sides. Just get a different value. I'm going to have x is greater than 1. And since it's an and, that means I want to write this as a compound inequality with my set notation. So I would actually start at 1. So x is going to be between 1 and 17. And I could write that in interval notation as well, going from 1 to 17. And I want the parentheses because I don't have that equal to. It's just less than and just greater than. And then visually, to graph this, let's start at 1, end at 17. I need some kind of number in the middle somewhere just for reference. I want an open circle on both of my solutions. And then since it's an and compound inequality, I'm going to shade between like a sandwich. And sometimes doing that graph first can help you write the set and the interval notation as well. Okay, and now for the modeling with inequalities. Here we have a bit of a word problem. We have a carnival that has two plans for their tickets. Plan A, you have to pay $7 entrance fees, but you pay 50 cents for each ride. Or there's Plan B, where you pay a $3 entrance fee, but you have to pay $75, or I'm sorry, 75 cents for each ride. So how many rides would you have to take in order for Plan A to be less expensive than Plan B? Okay, so we basically have two quantities that we're comparing. We're comparing Plan A and Plan B, and they want Plan A to be less expensive or less than Plan B. So Plan A, I'm going to kind of rewrite in an algebraic expression. Plan A, I have to, let's see, spend $7 to get in, and I have to spend 50 cents per ride. And then Plan B, to translate that, I have to pay a $3 entrance fee and 75 cents for every ride. So 75 times x. Now here it asks me how many rides do you have to take for plan A to be less expensive than B. So this was plan A. I want it to be less than plan B. So that is my inequality that I'm going to solve. And I have a little bit more room on the next slide, so let me rewrite this. We have 7 plus, I'm just going to say 0.5x is less than 3 plus 0.75x. Okay, now ideally we like all of our variables to be on the left side, so I'm going to subtract the 0.75x, and then I'll subtract the 7 over. And I know that's going to get me a negative 0.25x, but that's okay. Get a negative 4 here. And then when I divide by that negative number, remember we have to switch the direction of our inequality sign. So x now will be greater than 16. When you take negative 4 and divide it by negative 0.25, you get 16. So remember, this is in our set notation, x, such that x is greater than 16. If we were writing this in interval notation, we'd start at 16 and we would go greater than that, so we would go all the way to positive infinity. I want parentheses again around my interval notation. And now if I graphed this on a number line, I really just have one solution. So I'd have an open circle on 16, I want everything greater than it. Now, keep in mind though, this is just greater than 16. 16 is not part of my solution. I don't have a solid circle, I have an open circle. So really, the 16th ride is where the values will be equal to each other. So I would have to ride 17 rides. In order for plan A to be more cost effective than plan B. I would have to ride 17 or more rides. So make sure when you're doing these word problems that you're interpreting your answer appropriately, especially with these inequalities. When you have just greater than or just less than, it means something different than if you have greater than or equal to or less than or equal to. Okay, so there is your homework for this evening. Go ahead and work through those problems, and if you have any questions, come on in before school and see me.